All right, so we'll look at one of the problems from the homework that was about the number of cars in a household, whatever homework problem that was. And they gave us 0, 1, 2, 3, 4, I think 14 maybe? 5, and that 5 is actually going to stand for 5 or more, and that'll be okay. And we have a 9% chance of there being no cars in a household, 36%, 1 car, 35%, 2. These are from that homework problem. I just grabbed those out of the homework problem. I have some made up numbers for the next piece. But these so far are the ones that were on the homework problem. And that was problem 14. Okay. I want to describe this distribution. Okay. All right, so first the shape. Sure. Skewed right. Why are you saying that it's skewed right? What's telling you, from without looking at a picture, just looking at the numbers, why are you saying skewed right? Center is 1 and 2. There are my two highest bars. Good. One number to the left of that and 3 to the right, so that points out a little tail over here on the right. So sometimes you don't have to see a picture to tell if something's skewed. If you need a picture to tell if something is skewed, then you make one. Okay? So also in describing distributions, we need to find, what else besides shape? The center. Center, good. You said that. Okay. So the center that we're going to use for these is going to be the mean. And the mean we're going to abbreviate with a Greek letter mu. Mu. It's not a kitty. It's just a mu. And we're going to I did not. Oh, okay. I got to look. I got. No, it's near the end, right where the photos. Okay, I was just getting to that when lunch ended. Okay, I'll give you an autograph picture a little later. Okay. All right. So we're gonna have a formula. We're gonna have a formula for the mean of a random variable. And this formula is not just going to be for the mean of a random variable, it's also called the expected value. So this is a formula for expected value. And another name for this formula is weighted mean or weighted average. Okay? So this formula looks like, and I know you guys like these formulas. Yes, exactly. So we'll say the mean of this random variable x, and I'm going to make a little subscript x, like that, is going to be, got that little sum again, of every value that x takes on times the probability of that value. So that means my random variable can take on 0. It's there in my table. Let me go up and see if I can see it. There it is. 0, 1, 2, 3, 4, 5. I'll leave the probabilities down. So I take 0 times 0.09 plus 1 times the 0.36 plus 2 times 0.35 plus 3 times 0.13 plus 4 times 0.05 plus 5 times 0.02, and I get the mean of this random variable. And can you run that through for me and get me a number, please? 1.75. All right. Now, a couple of things about this number. First off, what is it describing? Well, my random variable is the number of cars per household. So we have an average number of cars per household of 1.75. Now, even though this is a discrete random variable, so you wouldn't think that I would want to throw in, 3/4 of a car, because it wouldn't make, 3/4 of a car doesn't make sense in this situation. When I find the mean, I don't round to the nearest integer. I leave it as a fraction. It does make sense as a fraction when I'm talking about the average number of cars. So don't think that you have to round this number to the nearest integer. Mhm. Mhm. Good question. We're heading into right now what's called parametric statistics. Parametric statistics deals with means and standard deviations. It's the older branch of statistics. This study of statistics has probably been around for 60, 80 years. If I talk about medians and IQRs, we are into what's called non-parametric statistics. That's a much newer field of statistics. Some of that theory's only been around for maybe 25, 30 years. So we don't go there as an entry-level statistics class. We don't get into non-parametric statistics. So we're going to, kind of from here on out, we're going to drop the whole median thing and just stick with analyzing everything with means and standard deviations and analyzing things in parametrics. Now, you get a little further along in statistics and you'll go back and you will look at the medians again, and that will become important again. But kind of from here on out till the end of the year, we're not going to worry too much about medians anymore. Okay? We will when we're analyzing one single set of data, and we will go back to that stuff that we did at the beginning of the year, but anything we do from now on is going to be means and standard deviations. Yes, ma'am? So, situations where you should round this number. No. When I'm talking about a mean or a standard deviation, you better give me a few decimal places. There is no standard as to how many decimal places I should round. But since I'm talking about one car, two car, three cars, rounding to the hundredths place, 2 decimal places is fine. If I were talking about million cars, I wouldn't go all the way out to 2 decimal places. My rounding may be at the nearest 100,000 or something like that. So you do reasonable rounding, but there's really no great guidelines for reasonable rounding. Okay. So what else did we need? Let's see, did I say anything about expected value? I did say something about expected value. So you would use the same formula if somebody said, well, how many cars do you expect to find in an average household? So you may not be asked for the average number, you might be asked for the expected number. And you would also say 1.75 because this formula is for expected value also. Usually